Hi all. Today we are going to discuss the topic free transverse vibration. So, when considering transverse vibration, we already state that what is meant by transverse vibration? The body moves perpendicular to the axis, right? So here the axis is marked as dotted line, and body has a weight W, and it is displaced by a amount delta, that is static deflection due to weight of the body, and also x means if the body is held for a time t, then in addition to the delta it will also displace through a amount x. So total amount, that is total deflection, is total amount moved from the mean position is x plus delta, right? Means next what we are considering here is we are considering the position of the body after time t, that is after it moving a distance x. So after time t the body moves through a after time t the body moves through a distance x, means at a time t, during that time interval the body moves a distance x. So the total force acting, means total force acting in the direction of motion of body is m into a, that is m into d square x by dt square, that is acting downward, and this downward motion is resisted by the restoring force. The restoring force is kx, that is acting in the opposite direction, that is upward. Here we are taking downward positive and upward negative. So restoring force is k into x. K means stiffness of the shaft. So restoring force k into x, and the force due to acceleration is m into d square x by dt square. So equating both these two, we are getting that is upward force is equal to downward force, so mx dot double dot equal to minus kx, or mx double dot plus kx equal to 0. This is called equation of motion. This equation we already derived using two methods early, equilibrium and energy method. And from this equation we are getting omega equal to root of k by m. This also we have discussed. So similar to the longitudinal vibration, here also we are finding angular velocity omega by using equation root of k by m. Then time period we are finding out, then natural frequency also we are finding out. So when we are finding the natural frequency, what we have to get here is we have to know a value delta here. Mean we have to know the value of delta here, means here already we studied, means it is displaced through a amount delta, static deflection due to weight of the body. So here what we have to know is we have to know what is the amount of deflection delta here. If we are looking the previous problem, you can see there, to find the natural frequency of transverse vibration, we just have to know delta here, and finally we are substituting that delta value in this equation, that is 1 by 2 pi into root of g by delta, to find the natural frequency. So we all only discussed about the case of a cantilever beam acted by a load at the end. So when a point load is acting at the end of a cantilever beam, the deflection is delta equal to WLQ by 3EI. That is the only case we studied, but it is not always same. So here we are going to discuss different cases. First we are discussing cantilever with a point load at the end, that is delta equal to WLQ by 3EI. And next we are studying cantilever with a UDL, uniformly distributed load. So delta equal to WL raised to 4 by 8Ti. And suppose the case is like this, means point load acting on this some simply supported beam. Suppose it is a simply supported beam and two loads are acting at a distance A and B. Means here you can see that the load W is acting at a distance A from left end and at a distance B from right end. So the delta will be W A square B square by 3EIL. Okay, 3EIL. And next we are finding simply supported beam with the UDL. So when it is UDL, that is UDL is acting on a simply supported beam, the equation is delta equal to 5WL raised to 4 by 384 EI. Clear? 384 EI. So next one, for a fixed beam, with the point load W, means here you can see that load W is not acting at the end. If it is acting at the end, then we can use the previous equation, means the equation we have studied in the previous problem. But here you can see that load W is acting at a distance A from left and B from right. So the delta equation is WAQ by 3EI L cube. So you have to remember all these cases. And one more case is there, fixed beam with the UDL. So with fixed beam with UDL, the equation is delta equal WL raised to 4 by 384 EI. So here, if you are comparing here, you can see here, it is almost same. Simply support a beam with the UDL. And here also you can see fixed beam with the UDL. If you are comparing the equation, 5WL raised to 4 by 384 EI for simply support beam with UDL. And for fixed beam with UDL, the 5 is replacing 5 WL raised to 4 by 384A only. So these are the different cases. You have to remember all these cases. Means the problem is asked based on this equation. So next we are discussing a problem. Before that, we are just giving some basic equation also. Means this is some of the standard equation. This thing you don't have to remember also. Means only in some cases this is asking. This is the direct equation. Means the what is the basic equation? That is 1 by 2 pi into root of 1 by 2 pi into root of g by delta. This is the standard equation. So in this equation we are substituting all this value 2 pi g etc, and delta is the only unknown thing here. So these are different things we are getting. The first two equations are almost similar. Means natural frequency beam simply supported with UDL. Second one, natural frequency beam fixed at both ends with UDL. This is the equation obtained by substituting the value of 2 pi and g. This is the final equation. But the third equation is somewhat important. This is the most important case. This is the usual case asking for university exam also. Means natural frequency beam for a shaft subjected to a number of point loads and UDL. Means here both the point load and UDL is coming. So this equation is very important. When both the UDL and point load is coming, the equation becomes Fn equal to 0.4985 by delta 1 plus delta 2 plus etc plus delta S by 1.27 raised to 0.5. This method is this equation is called Dunker-Lewis method. For delta 1, delta 2 etc means the deflection due to point load, and delta S means deflection due to UDL. Next we are going to discuss a problem. This is the equation we are usually using. Suppose in a case a shaft subjected to a number of point loads only. Means if there is no UDL in a case, in a shaft if there is no UDL, then delta S becomes 0. So the equation becomes Fn equal to 0.4985 by delta 1 plus delta 2 etc raised to 0.5 only. Delta S disappears if there is no UDL. So next we are going to discuss a problem. A shaft 50 mm diameter and 3 meter long is simply supported at ends and carries 3 point loads 1000 Newton, 1500 Newton and 750 Newton at 1 meter, 2 meter and 2.5 meter respectively from the left support. The Young's modulus of the shaft material is 200 giganewton per meter square and the frequency of transverse vibration. So this is the question usually asking. This was one of the similar question used in your asked in your previous university exam. So just understand it carefully. So diameter 0.05 meter, length is given 3 meter, W1 first load 1000, second 1500, third 750. Young's modulus 200 giganewton per meter square. So this is the pictorial representation. So when we are getting a question like this, first what we have to do is we have to convert it into a proper figure. So 3 loads are acting here from the left at a particular distance of 1 meter, 2 meter and 2.5 meter respectively. So that is what we have represented here. First load 1000, second load 1500, third load 750. We are marking point also A, B are the two extreme points, and in between we are marking C, D and D at a distance given in question also. So what we are doing here is first we are finding moment of inertia. So diameter is already given 5d raised to 4 by 64 since it is a circular shaft. Then we are finding deflection due to W1 since it is a point load. Since all these are point load, we are using which equation? Means here it is given simply supported beam with point load. So different loads are acting. So this is the case, point load acting on simply supported beam. So we are using that equation. So what is the equation? W A square B square by 3 EIL. So what we are doing here means here you can see AB. AB means A means distance of the load from the left side. B means distance of the load from the right side. So if you are considering 1000 Newton, from left it is acting at a distance of 1 meter. From right it is acting 3 minus 1, that is 2. So from left it is acting 1 meter, from right it is acting 2 meter. So we are finding both the distance 1 and 2, and E 3 EI. E we know, I we know, L total length of the beam, that is 3 meter. Similarly, we are finding delta 2, that is due to 1500, and also delta 3, that is due to 750. So we are finding delta 1, delta 2, delta 3 when a number of loads are acting. What is the equation? We are using the Dengerle's method, this one. Here delta S is 0 because there is no UDL. So finally we are substituting Dengerle's equation, that is 0.485 by root of delta 1 plus delta 2 plus delta 3. So we are getting 3.5 hertz. So this is one of the usual question asked in exam. So just study it carefully. Okay, thank you.